Thanks a lot. Hello and welcome, everyone. Today we're going to talk about big data and analytics workloads on Amazon EFS. My name is Joe Disher, and I'm the Senior Product Marketing Manager for Amazon EFS. And here with me today is Daryl Osborne. Daryl is a solutions architect specializing in file services here with us at AWS. This session is structured around the phases people commonly go through when building out a cloud-scale big data solution on AWS. First, we'll talk about the different storage platforms that are available, diving into more detail on Amazon EFS and the unique benefits it has to support building out your big data and analytics solutions. In the second phase of today's discussion, I'll hand things off to Daryl, where he'll define big data and analytics workloads and discuss the AWS services that support big data deployments. In the third phase, we'll dive deeper and discuss some specific examples with Amazon EFS and big data. And finally, we'll wrap up with some key tips and tricks and links to some valuable resources. First, let's discuss some general guidelines for choosing your storage platform. As you start thinking about that, which storage solution makes the most sense for your application workloads, there's a few things to keep in mind. It all starts by understanding your options well enough to assess the pros and cons as they apply to your application workflow. Next, you need to consider the features and particularly the performance. And finally, how will costs stack up for you once you're in full production? There are three fundamental storage types that I'll just touch on before we dive deep on the Amazon EFS architecture. First off, file storage is the typical storage type everyone uses when they want to share files between a group of users or applications. Block storage is often referred to as direct attached, and it's locally attached, which is ideal when you need dedicated storage for a single host as opposed to sharing. Object storage is stored in a flat address space and uses a simple API to access the data stored as objects. The key difference compared to file storage is that there are no hierarchical directory structures used to organize and search for data. So let's drop back to file storage. Why is file storage so popular? First, it works natively with the host operating system. There are no APIs to work into the workflows or to embed into your code. Second, it provides shared access to multiple users and or applications while maintaining consistency and locking functionality. And finally, to access shared file storage, everything is stored in a hierarchical namespace, which means you can search through directory trees that you can logically organize for yourself. So let's look at performance. When considering performance of the various storage options, it's pretty straightforward. Dedicated access to block storage delivers really good throughput performance for a single host and actually the lowest latencies. While file storage offers a shared namespace that gives you great throughput for all of your hosts with low latencies in line with storage accessed over a network. When looking at object storage performance, you have to consider higher latencies, but despite that, you can expect to see some fantastic throughput performance when you're accessing your objects with a large number of clients. So before I talk specifically about Amazon EFS, let's consider what it would take you to create a do-it-yourself shared file server in the AWS cloud. First, you'd have to allocate an EC2 instance for compute with some EBS block storage behind it, and then add an NFS server or some other file sharing software so your clients can access the shared storage. And to make sure you have availability and redundancy, you'll have to do that once again in another availability zone, which means network transfer costs between AZs need to be taken into consideration as well. And all of this comes with the complexities of the initial setup and the long-term challenges of maintaining and dealing with any technical problems that might come up. And this undifferentiated heavy lifting keeps you and your teams away from doing the things that really provide value to your business. So now let's talk about Amazon EFS. Amazon EFS is a fully managed service that is easy to set up and scale file storage in the AWS cloud. In just a few minutes and a few clicks in the AWS Management Console, you can create a shared file system that is accessible to Amazon EC2 instances via a file system interface using the built-in network file system protocol, and supports full file system access semantics such as strong consistency and file locking. When we designed EFS, our first core tenet was simplicity. Since it's a fully managed service, there's no hardware, networking, or file layer to manage. With just a few clicks, you can create a scalable file system in just a few seconds. There's also a simple pricing model, but I'll talk more about pricing in just a little bit. Our second core tenet was elasticity. EFS file system is unique in that it automatically grows and shrinks as you add and remove files. There's no need to provision storage capacity or performance. You pay only for the storage capacity that you use with no setup charges or minimum fees. Our third core tenet was scalability. EFS file systems can grow to petabytes of capacity. The throughput the file system can drive scales automatically as the file system grows, while providing consistent low latencies regardless of the file system size. This scalability extends to clients as well, supporting thousands of concurrent connections. And across all of these tenants, we designed EFS as a platform to provide high availability and highly durable data storage. Okay, so changing gears a bit, let's talk about EFS security features. EFS provides a variety of mechanisms to control access to your data and to your file system resources. First, you can control network traffic using Amazon VPC security groups and network access control lists. Next, you can control file directory access using POSIX permissions. Third, you can control administrative access using AWS Identity and Access Management action level and resource level policies. And finally, fourth, you can create a file system and can enable encryption of data at rest, so all of the data in your file system is encrypted. Encryption of data at rest can only be enabled during the file system creation. You can also encrypt data in transit. Data encryption in transit uses industry standard transport layer security, or TLS 1.2, to encrypt data sent between your clients and your EFS file systems. This is configured per client for each file system using the EFS Mount Helper tool. So what AWS regions is a EFS available in today? Today you can use EFS in 8 different regions: US West, Oregon and Northern California, US East, North Virginia and Ohio, in Europe, Ireland and Frankfurt, and in Asia Pacific we have Sydney and Seoul, and we have many more to come throughout this year, so stay tuned for that. Now let's talk about the economics of EFS. Pricing for EFS is super simple. There are no minimum commitments or upfront fees. Since it's a fully managed service, there's no hardware or other infrastructure to manage, and the elastic nature of EFS means there's no need to provision any storage. It automatically grows and shrinks as you add and remove files. There are no other fees, charges, or billing dimensions. There are no request charges. It's a simple price per gigabyte per month, and because our costs vary from region to region, so does the price. So remember the do-it-yourself setup we talked about before. Keep in mind the various costs that exist. You'll have to pay separately for compute with EC2. You'll have costs for EBS volumes for storage. And of course, you'll have inter-AZ costs so you can have high availability. And then, of course, there's any software licensing and maintenance costs. So let's look at a quick example. To store 500 gigabytes at 30 cents per gig per month, it will cost you $150 per month with EFS. To do the same thing, building it yourself, considering the necessary over-provisioning so you have enough storage, it will cost about $540 per month. Pretty considerable. And this isn't counting the soft costs like software licensing and maintenance, time for your people to configure and manage, and of course, just the complexities that can come from any challenges that come up. With EFS, you would save 70% compared to the do-it-yourself solution. So really good savings by going to a fully managed solution with EFS. Let's talk about the ideal use cases for EFS. From the start, we designed EFS to serve the vast majority of file-based workloads, covering a wide spectrum of performance needs. This spectrum runs from highly parallelized scale-out jobs, those workloads that require the highest possible throughput, things like big data applications, which we're going to talk about today, and media workflows, to single-threaded, latency-sensitive workloads, and pretty much everything in between. As a testament to the diversity in workloads and applications that EFS can serve, here's a sampling of some customers who are using EFS today. I won't read through all the logos, but I'll just highlight a few for you. We have folks like Monsanto and Toast using EFS in their big data solutions. Castora is using EFS for their retail marketing analytics platform. Atlassian uses EFS for their own Jira implementation, and Zynga in the gaming space, they use EFS as part of their transcoding workflow, and so many others like Netflix, Pinterest, Thomson Reuters, JD Powers, Disney, Expedia are all using EFS for a variety of workloads. So let's shift gears a little bit. I'm going to hand things over to Daryl now, and he'll discuss the broad range of services that AWS provides to help you build and deploy big data analytics applications quickly and easily.
Great. Thanks, Joe. Appreciate it. Well, AWS provides a broad range of services to help you build and deploy big data analytics applications quickly and easily. So, what is big data and big data analytics? So while there are plenty of definitions for big data, most of them include the concept of what's commonly known as the 3 V's. This concept, it also describes some of the management challenges that cannot be solved by traditional means. So what are these 3 V's? Well, first we have volume. This ranges from terabytes to petabytes of data. Next, we have variety. So this includes data from a variety of and a wide range of sources and formats. So this could be weblogs, social media interactions, e-commerce or online transactions, financial transactions, things like that. And then finally, we have velocity. So velocity, increasingly, businesses have stringent requirements from the time data is generated to the time actionable insights are delivered to users. Therefore, data needs to be collected, stored, and processed and analyzed within a relatively short window. This could range anywhere from a day to really real-time information. So with new tools that address the entire data management cycle, big data technologies make it technically and economically feasible not only to collect and store large data sets, but also to analyze them in order to uncover new and valuable insights. In most cases, big data processing involves a common data flow, from collection of raw data to the consumption of actionable information. And what we want to do is we want to step through this workflow right now. First, we need to collect. We need to collect the raw data. Again, this could be transactions, logs. It could be data from mobile devices. This is the first challenge many organizations face when dealing with big data. Next, we have store. So any big data platform needs a secure, scalable, and durable repository to store data prior or even during or after the processing tasks. So depending on the specific requirements as well, you may also need to store temporary data for in-transit transactions. Next, we have process and analyze, and this is really where analytics fits in. This is the step where the data is transformed from its raw state into a consumable format, usually by means of sorting, aggregating, joining, and even performing more advanced functions and algorithms. And finally, we have consume and visualize. Now, big data is all about getting high value, actionable insights from your data sets. So we have a variety of resources available to our customers to help you run big data analytics workloads on AWS. As I mentioned earlier, you have a need for a secure, scalable, durable repository to store data prior or even after processing tasks, including temporary stores for data in transit. So that the attributes of Amazon EFS that Joe mentioned earlier makes EFS a compelling option and a serious contender for running big data and analytics workloads. AWS gives you fast access to flexible and low-cost IT resources, so you can rapidly scale virtually any big data application, including clickstream analytics, fraud detection, even recommendation engines, event-driven ETL, and even IoT processing. With Amazon EFS, cluster nodes can share access to a file system that scales to petabytes in size and is available to achieve multi-gigabytes per second throughput. Last year, I worked with a customer to ingest a large amount of data. And in this video, as I show you, what we were doing was we were ingesting a large amount of data from an S3 bucket to an Amazon EFS file system. And they needed to do this to process and analyze this data set. So their application, which required a file system access to the data, could actually process the data. So I did a screen capture, and this is the CloudWatch graph displaying the throughput of the file system during this process. As we can see, we are achieving high levels of throughput, reaching 15 billion bytes per minute, which equates to roughly 3 gigabytes per second. As we speed up this video, we'll be able to see that we experienced a very consistent throughput level as this fleet of instances ingested all of these S3 objects into the same file system. So the entire process took approximately 1 hour. And during this hour, we were able to ingest just under 11 terabytes of data. I think the actual number was around 10.94 terabytes. And we did this using a fleet of 40 EC2 spot instances. I believe they were C4 large instance type. And because of the per second billing for EC2, we only had a 95-cent compute cost to ingest this entire data set. So it was a very efficient, very economical way to ingest a large amount of data into an EFS file system. So Informatica Power Center is a data integration solution that can process billions of records and connect to a vast array of data sources like Amazon EFS. The Power Center services running on Linux can write files such as cache, source, and target files to an Amazon EFS file system. Informatica Power Center is available as a quick start. So quick starts are built by AWS solutions architects and partners to help you deploy popular solutions on AWS based on AWS best practices for security and high availability. These reference deployments really implement key technologies automatically in the AWS cloud, often with a single click, and they can do this typically within an hour. You can build and test your production environments in just a few steps, and you can start using it right away. So if you're interested in running Informatica Power Center on AWS, we recommend you launch it using this quick start. And you can see how Informatica Power Center accesses cache source and target files stored on an EFS file system. So another example I want to talk about is SAS. So SAS grid computing environment is one in which SAS computing tasks are distributed among multiple computers on a network, all under the control of SAS Grid Manager. In this environment, workloads are distributed across a grid of computers. A SAS Grid environment in the AWS cloud provides the elasticity and agility to scale your resources as needed. This diagram here is from the SAS Grid infrastructure on AWS Quick Start, which was developed by SAS and Core Compete, who is an AWS partner and a member of the AWS Partner Network. SAS Grid requires a network share that all computers on the cluster can access. This can be an NFS mount or a directory on a SAN or some types of other mount, really any method of creating a directory that is shared among all the machines in the grid. So while this diagram shows Amazon EFS sharing the bootstrap information with SAS Grid and the other storage nodes, EFS can also be used as the underlying shared storage on the grid. So SAS recently updated their white paper titled Important Performance Considerations when Moving SAS to a Public Cloud. So in this white paper, they talk about the important performance considerations you need to think about when running SAS on public clouds like AWS. So some of these recommendations are really documented here to help you, to assist you in your deployment. So if you're going to place your SAS home and SAS configuration files on EFS, we do recommend you disable file locks. You can do this using the SAS v9.cfg file. And to do this, what you would do this for your SAS home directory. And what this does basically is that it tells SAS to disable file locking on this directory. You need to do this because any one particular file on an EFS file system can have up to 87 locks concurrently across all the users of the file system. And if you have a large scale-out cluster for SAS, you may run into this limit if you have multiple processes and multiple instances running concurrently. Another consideration is to really understand the network performance of the EC2 instance your workload will be running on. So we want you to keep in mind that the network performance is very important when accessing a shared file system over the network. So SAS does recommend using i3 8 extra large instances when running SAS workloads, due primarily to its CPU memory and dedicated 10 gigabit network performance, and the use of internal NVMe drives for SAS temporary space. So keep in mind that the maximum throughput each EC2 instance can drive a single EFS file system is 250 megabytes a second. So in order to achieve higher throughput than this, we recommend that you mount multiple file systems to each EC2 instance. As an example, during some SAS simulation tests that we ran, in this graph, we see that this one EC2 instance was able to drive high levels of throughput to EFS with multiple EFS file systems mounted to it. We see consistent throughput during a read and write test in the middle of the graph. And we also see some varying performance as we were doing series of different file system operations during other SAS tests. Now, we do recommend you start with our quick start. So look at this link and access the link to learn more information about the Quick Start. Here you can review the deployment guide. You can get access to the Quick Start CloudFormation templates that create the environment. You can run this in this environment in an existing VPC or in a new VPC, and very quickly you can get up and running this SaaS grid in your account in the region that you select. With that said, I'd like to turn it over to Joe to wrap us up.
Great, thank you very much, Daryl. So let's wrap up. We go. Deployments. First, make sure to use Linux kernel 4.0 or above for the best performance and stability. We highly recommend using the EFS mount helper. I mentioned that early on, which is free to use, and it's especially useful if you're intending to encrypt your data in transit. Using larger I/O sizes and aggregating I/O will generally give better performance. Since EFS uses a distributed architecture, you can really improve your overall performance by using multiple threads when accessing EFS. Along those same lines, if you create multiple directories, you can also improve performance. And as you might expect, using multiple instances also takes advantage of the distributed architecture of EFS. And finally, make sure to monitor your EFS usage and performance so that you can understand if there are any opportunities to tune your application or workflow to maximize your experience with EFS. I want to remind you that we have lots of resources available to help you in your journey with EFS. As Daryl pointed out, we have a quick start available for Informatica available. Here's the URL for you. We also have another one for SaaS Grid to help you out as well. And please bookmark the EFS resources page, as we're always updating it with new content to help you with all of your EFS deployments, between user guides and resources for the quick starts like Informatica and SaaS Grid. We also have reference architectures and other white papers available on this page. If you're looking for more videos from reInvent sessions or webinars, you can go here as well. We maintain a library out there so that you can stay up to speed on all things EFS. So with that, I'd like to say thank you very much for your time and attention today. Now I'll hand it back over to our moderator for a bit of housekeeping before we respond to some Q&A.